Hello and welcome to SudoKanard. I've been requested to do a setters video and I thought I would do a video in which I really create a puzzle. And I waited till I had an idea that seemed suitable for such a video, and I've had that idea. I just hope I'll be able to pull it off, but if you watch the video, it means that I've kind of put it off. Alright, so the set of rules I've chosen for this puzzle is on the weird side, I guess. It's an ambiguity puzzle, which means that I'm about... Oh, sorry, I'm not clicking in the right window. So I'm about to put clues outside the grid, and those clues will either be Skyscrapers clues or Parity Party clues. And I have to explain what this all means before starting to create the puzzle. Well, Skyscrapers is quite a standard rule, even outside Sudoku. So let's imagine you're... Oh, sorry, that's a letter, that's not a digit, definitely. So let's say you've put, well, the usual, well, that looks like the first row of a Sudoku puzzle. Then those numbers are interpreted as heights of buildings. And a building hides from view the buildings that are smaller. For example, if you're watching from the left, you'll see building 3, you'll see building 5, but you won't see buildings 1, 2, and 4. They are hidden behind building 5, and you'll see building 3. So you're seeing 3, 5, 6. So you see 3 buildings, and the skyscraper clue will be 3 in this case. And from the right, you see that 6 hides everyone. So 6 is the only building that is seen, and you put a clue 1 in this right margin. So that is the way you do, well, skyscrapers clues. But then the ambiguity will be between skyscrapers and Parity Party. Parity Party is a much more exotic set of rules, which was created by my good friend Glam Hippo. And you also put a number in the margin, but this number is the sum of all digits until you meet the first odd digit or the first even digit. So for every row or column or whatever, well, row or column, nothing else, there are 2 possible totals. Let's take the same example. If you just take all digits until the first odd digit, then the sum is 3, obviously. But if you go until the first even digit, then the sum is 11. And, well, 11, oh, sorry, 11, that's it. So you see that for such a layout, what did I do? Oh, that's it. Oh, right. There are 2 possible clues for a Parity Party. And if you are given the number, you have to determine whether you stop your sum at the first odd digit or the first even digit. From this side, the sum could be 6 with just digit 6, or if you stop at the first odd digit, it would be 13. So lots of options here. Oh, actually, I will let it, because you see that 3 would work both as a Parity Party clue for this digit 3 and for a skyscraper clue. And I haven't really thought about this. which clues are so ambiguous that they can work both with both set of rules. And my point is that I want to put, well, clues on the borders, and it's up to the solver to determine whether there are parity party clues or the skyscraper clues, and I should not exclude the possibility that they be both of them. So how do I set such a puzzle? And it's the first time I've used this set of rules. I've just thought about it. So what do I do? First, I need to understand how all of this works. I want clues that can be both. And skyscraper clues are between 1 and 6, so for parity party I will use only sums from 1 to 6. Let's think about a clue of 1. If this is a skyscraper clue, then it means that we put a 6 here. That's the only building that is seen. But if we use this as a parity party clue, then it can only be digit 1. So you see that with a clue of 1, we get either a 1 or a 6. And just this remark is the beginning to create a puzzle. Let's say I put the clue 1 here and the clue 1 there. Let's try this, just for the sake of trying something. And let's switch to solution mode with Sudoku mode. And thinking of this, we just noticed that if we have a skyscraper clue, then that's a 6. If we have a parity party, then that's a 1. And same here. And from a solver point of view, we have a 1-6 pair right from the get-go. And that's absolutely all this gives. And so that's a start. I just put clues, I've just seen what, as a solver, I can deduce from that. And then I have to work out what I'm doing next. But just notice that I've put the ones here, but I could have put a 1 here, a 1 there. I could have split them instead of putting them just next to each other. Right, what am I doing next? Well, this begins very much like a theme of repeated digits. I'm very tempted to try something like, let's say 2 and 2. That only seems right. But before doing that, just let us think, let us ponder what this implies. Well, from a parity party point of view, 2, we'll put digit 2 here. Not this fancy French letter, just digit 2. But from the perspective of skyscrapers, 2 could do a lot of things. It could be, well, let's use Sudoku, it could be a 5 with a 6 basically anywhere in the column. It could be a 4 with a 6 anywhere in one of those positions. It could even be a 1 followed by a 6. It could be not anything, but pretty much anything, yes. So it doesn't give a lot of information. So I just keep in mind the fact that at some point it should be interesting to use a pair of 2s, a pair of side-by-side 2s like this. But 2 is not a powerful clue. It does not impose restrictions right from the get-go, contrary to those ones. So let's move on to more extreme clues. And a more extreme clue is definitely a 6. If you're using a skyscraper, then you must see all 6 buildings, which means that they must be in ascending order from your point of view. And you see that this clue as a 6 won't work because of this 1-6 pair. And because of this, a 6 clue in such a position would necessarily be a parity party clue. And that's interesting because I've solved quite a bunch of parity party puzzles. And I know that 6 as a parity party clue has only 2 options. Either it's a naked 6, just the digit 6, or you start with even digits, with odd digits, sorry. And in this case, the only way is to have a 1-3 pair followed by a 2. So knowing that, I think a double 6 here would work pretty well for my purpose. Let's switch to solution mode. So just as we had noticed that there were only 2 possibilities for this double one, for 6 there would be actually 3 possibilities. The skyscraper possibility with digits from 1 to 6 in ascending order, but this is, in this very case, it's forbidden because of this 1-6 pair. So we are left with only the 2 possibilities that come from parity party. So we know that there has to be a 6 somewhere in one of those 2 cells. There must be a 6. And on the other row, it's 1, 3, and 2, and therefore there must be a 2 here. And the 2 is not correlated to this 6. I mean that if 2 is here, then 6 is here. If 2 is here, it's with 1 and 3, and that's it. And we know that 4 and 5 will be either here or there, but that doesn't seem to be very useful right now. So that's a start. This double 1, this double 6, it already does something. And we have to keep in mind what I've not pencil marked. All right. So I'm almost tempted to put a 2 here now because I know that this won't be a parity party clue, it will be a skyscraper clue because a parity party clue would put digit 2 here and is forbidden by this corner pencil mark. So this has to be a skyscraper. And I know basically nothing else about this skyscraper, but I know it doesn't start with a 6, because 6 would be with a clue 1. But this skyscraper could be almost anything. Well, so it doesn't start with a 2 either. So I could do something a bit crude like this, putting 4 candidates in this cell. And in some cases I do that. But I don't think that would be very useful right now. So do I put a second 2 here or a second 2 there? I think I'll leave it like this for the time being. Let's move on to some other clue. We already saw when I was explaining the rules that 3 could do a lot, and it would be very tempting to have 3 have 2 rows, like in my example that I came randomly on that example, and it was quite interesting, but let's not get carried away. Let's try a clue of 5. 5 as a skyscraper is quite powerful because we see 5 buildings, so there's only one hidden building. And in this case, we would have 6 in one of those cells, because we must see 4 other buildings, and it could be those 4 buildings, or it could be 4 out of the first 5 buildings, but 6 couldn't be in any of those cells, or if 6 were here, I could see at most 4 buildings. So we see that it doesn't work. It just doesn't work because of this. So 5 here would have to be a parity party clue, and there would be several options. Just plain digit 5, or 2 and 3, or 1 and 4. So we would just know that this is not a 6, which is not very helpful. But this, if I put a 5 here, then this is parity party. And then I'm tempted to put a 5 here, because let's remember that this 2 is a skyscraper's clue. If this 5 is a skyscraper's clue, well, let's ponder what we can deduce from that. If this 5 is a skyscraper clue, then it means that we have 5 buildings that are visible, and 6 can't be here. Well, 6 will be, well, 6 can't be in those cells, and 6 can't be in this cell because of the 2. So 6 will have to be here, and all digits here will be seen, but it's not possible because 2 here can't be seen. That's some interesting logic. I like that. So 6 can't be here because, well, if we have 2 here, then here we can't have digits small, all smaller than 2. There must be a 3 or a 4, which will hide this, and we won't ever see 5 buildings. So this 5 can't be a skyscraper clue either. So they are both parity party clues. And what could this be? It could be digit 5, or it could be a sum. And in this case, you see that this sum can't include a 2, in which case it's a 1-4 pair. So this is a bit restricted. We know that this is either 1, 4, or 5. And I'm tempted to leave this in this position. So this is parity party, and this is skyscrapers. And at this point, it could very well be that those clues yield absolutely no solution. It could already be impossible. And because the genre I've chosen, the variations I've chosen, are not supported by, say, Sudoku Lab or F puzzles, you all have to find out by yourself. It all comes down to your solving skills to find whether this has a solution or not. Well, so these clues don't give a lot of constraints, but we already have some bits of logic, and I like that. All right. Let's say that's it for 5 for the time being. What about 4? What about a clue of 4? Let's say I put 4 here. If this is a skyscraper clue, then 6 won't be here, so 6 will be somewhere there. Mhm. And so, what else? Oh, something else is that a skyscraper, it won't start with a 1. So the minimum digit here is 2. So it could be 2, 3, 4, 6, something like that. So this would be 2 or 3. And that would be interesting for an interaction with this 5, because then this 5 would never be 2 and 3. So this is at most 3. So I think that's correct. But then what if this is a parity party clue? Then the only option is digit 4. I leave it as an exercise. That's really not hard. So the options are 2, 3, or 4. 2 or 3. If it's just a skyscraper, and 4 if it's parity party. Both options have an impact of what can happen here, on what. Actually, if I put a 6 here, and this is a skyscraper, something interesting is that I can never have a 5 here, because no parity party would work with a 5 in this position. So as a skyscraper, if 6 is here, then it must be 2, 3, 4, in which case this is 1 or 5. Either 1 plus 4, or just digit 5. And then by Sudoku we get here a 1-5 pair, and this is 4. And this is completely broken in this case, because starting with 4 and 6, it won't be a skyscraper. This won't be a skyscraper clue. We only see 2 buildings, and it won't work with parity party either. So what I'm seeing here is that 6 here is not a valid option if we assume this to be a skyscraper clue. Of course, this is no easy bit of logic. And you don't need your intended solution for the final product to be that complicated. But this is part of exploration of your constraint, of my constraints in this case. So that's coming up with complicated ways of reasoning is part of this exploration. So what we've seen here is that if this is a skyscraper clue, then 6 has to be here. And let's continue with this. For the same reason, 5 can't be here. That's very interesting. We've seen that 5 can't be here, and 5 can't be here, because those are parity party clues. And 5 can't be here because we would see only 3 digits. So, assuming again that this is a skyscraper clue, 5 must be here. And in this case, this is a 1-4 pair. Now, we must see 3 buildings, and actually we know that 1 will be hidden, and 1 will be the only, well, we have two buildings that are hidden. 5 is hidden, 1 is hidden, so 2 must be seen. So this is either hidden 1 or 3. Knowing that, so this is one, maybe, oh sorry, I should have switched to solution mode. So we are still under the assumption that this is the skyscraper clue. So we know that 6 is here, we know that 5 is here, and we know that 1 won't be seen, so that has to be 2. This is either hidden 1 or visible 3. If this is 1, then this has to be 3. If this is 3, then this has to be 1 or 4. And this is either, and this is 1 or 4 as part of the 1-4 pair. So those are valid options. But now, what can this be? It won't be a 2 because of this. It could still be a 1-4 pair, and it could still be a 5, in which case 6 is here. This is one of those 3 digits. Oh, this is 2. That's 2-3 pairs, so that's not 3. I'm just exploring there again. And the interesting part of this is that it really seems to work. Now let's see the implication on these two. Digit 6 won't be here, so it must be here. And 1, 6 here. 1, so this is 3 and this is 2. Very important to ponder what happens. What am I doing? No, sorry. I'm messing it up. So 1, 3, 2 would be with a 6 clue. 6 clue for Parity Party. And here it would be 3 or 5. 2, 3 or 5 here. But let's remember that 3 has to be in this area because one of them starts with 1 and 3. So 3 wouldn't be here, so that would be a 3. All of this is really working. All right, so in this case, that's really, really interesting. Something I would do is just take some paper or just take your picture of this or a snapshot. Oh, I'd be doing this. I use a snapshot. Right. Right, so I've taken a snapshot of this, and now I just backtrack. Let's remember that this is a 2. If we're assuming, so, sorry for being inarticulate. Well, what I mean to say is that just using this 4 and assuming that it's a skyscraper's clue, I've come to all those deductions, and they really seem to hold. I mean that it doesn't break. Now, the interesting part is that if this is not a skyscraper's clue, then it has to be a Parity Party clue, in which case this is a 4. So this must be 2 or 4. So now I backtrack. until the moment I decided that this was a skyscraper clue. And the other option is that this be a 4. And I'm tempted to just put a second 4 here. And now let's try to see what happens if this is a skyscraper's clue. And we know that if this is Parity Party, actually there's a very good reason why we must have one of each. They can't both be Parity Party because Parity Party places a 4. And they can't both be skyscraper clues because a skyscraper clue puts 6 in this box, and there can only be one digit 6 in this box. So it all comes down to finding which one is a Parity Party. Oh, sorry, I'm looking. Yes, I think it could really work. Let's try to see if this can be a skyscraper clue. In this case, 6 must be here, but because of this, it has to be here. So this digit here is hidden. And we know that digit 1 will be hidden, so that's the same logic, and 2 has to be here. And 4 has to be here, obviously. And now, knowing this 5 can't be 2 plus 3 or 1 plus 5, so this has to be a 5. And we know that 1 must be hidden somewhere. Oops, what did I do? Let's remove this. So this digit is hidden, this digit is hidden, so this one is seen. So it can only be a 3. In which case this is 1 or 4. And this breaks because now this 5 can't be satisfied. It would have to be 1, 4, and it would break. So that's quite a look ahead. But it works. So this one is a 4, and this one is a skyscraper clue. And it will be exactly the same logic as previously, but first let's remove 4 from here. So what happens? So this is a skyscraper clue, so we know there must be a 6 somewhere here. We saw that 5 can't be here, that 5 can't be here. Because of those, we saw that 5 can't be here because of the skyscraper clue. So 5 has to be somewhere there, and therefore this is 1, and this is 4. So you see, we don't have to do that difficult logic that I had used earlier to eliminate the possibility that 6 be here, because we have new information. So 6 is here, that's a 5. Here we have a 2-3 pair. 6 can't be here, so 6 is here, and that's a 5. And here we must, so we see the 4, we see the 6, we must see only 2 buildings here, so 1 is hidden, but 2 is the first, because 3 would hide all other digits, and here we have a 1-3 pair, and that's a 3-5 pair. So this 2 means that 6 is in second position. Just here, and as previously I had stated that one of those parity parties starts with 1 and 3 somewhere, so that can't be a 3, so 3 is here, and this is a 2-5 pair, and there has to be a 4 somewhere, and I must recall that 4 is next to the 6. So on one row we have 6, 4, 5, And on the other row, we have 1, 3 in some order and a 2. This is going very well, I must say. I really like the way it's happening. I'm just not sure I'll be able to pull off the double of 3 unless I can. Oh, that would be fantastic. That would be nothing short of a miracle. Could this be real? Because no, it wouldn't work. Because as a parity party clue, 3 would work with an initial 3. It would work with 1 and 2 at the beginning. But as a skyscraper clue, it must start with a 3 as well. So I can't put both 3s here. But one of them I can. And it would be very powerful because it would just give... Well, let's try to put a 3 here. So this has to be a 3, and it says that this is not the row with 1, 3, and 2. So it would be a 6 here, 4, 5, 2, 5 here, and a 1, 3 pair here. 1, 2 pair here, 6 here, 4 here. And that's a bit disappointing. It's all happening too fast. So I don't think I'll do that. What am I doing? Yes. So I won't put a 3 here. Now let's ask ourselves what happens if we put a 2 here. This is very symmetrical in terms of design. I must watch how much battery I've got left. So what does a 2 here do? Could be digit 2. Really, nothing wrong with that. Could be a 3 with, let's say, a 2 and a 6. No, it wouldn't be digit 3. I'm talking nonsense. It could be digit 4. Oh, and actually it could only be a 2 or a 4. But let's ponder the implications of digit 4. So 6 would have to be somewhere here or there, but actually 4 hides all other digits. So we would have a 5 somewhere here, a 3 somewhere here, put a 4 here. 2 or 5, 1, 2, 5, 2, 5, 2, 3. 6 would be somewhere here. Well, that's not saying much. Let's not forget that the puzzle has to resolve in the end. The puzzle has to be solved. So we've done a lot, but a lot still has to be done. So this 2 is not a bad idea. So this would be 2 or 4. That's the main thing. Let's think about digit 3. a clue of 3, which was not so powerful at the beginning. Let's try a 3 here. What are the options? Can't be digit 3. It could still be 1 and 2. Oh no, it could not, because there has to be a 4 somewhere. So that's a skyscraper clue. Interesting. So 4 can't be here because I will need to place 5 between 4 and 6, and 5 is behind the 6. So 4 is here if I do that. That's 1 or 2. And this is fulfilled. In which case this is fulfilled. Now I'm just wondering what happens if I put a second 3. Here, or I could put it there. Well, symmetry has been revoked, but then just the neighboring pairs would be fantastic. If I put a 3 here, then Parity Party is no more an option. But skyscrapers can still happen with a 5 here, 1, 2 here, in which case this is 5, this is 4, this is 5. That's a 2-3 pair. Well, in this case, it all seems to work, but I don't see anything to provide any final disambiguation, I'm afraid. I'm wondering whether this 3 was such a good idea. Not easy. Well, let's... What did I do? Oh, no, no, no. Oh, I messed up. Sorry. That's terrible. I put the video on pause and tried to fix that. All right, I think I've found where we were before I tried to put a clue of 3. Oh, and I've missed some easy deduction here. All right. So what should I do from here? Actually, I'm thinking before putting another clue, I should do some classic Sudoku. I mean, just see, this can only be 2 or 4. This can only be 2, 4. There has to be a 3 here. There's a 5 somewhere here, so this is something that you sometimes need to do when you're setting a puzzle. Just see where you are. There has to be a 2 somewhere here. And you see that some of the cells have very few options. And a clue of 3 here would be very strong. If I put a 3 here, then this has to be 4, 5, 2. It has very strong implications. So let's try a 3 here. So 3 here makes this 4, this 5, this one, that's a 2. It's 4, 5, 2. Here this is 1, 2, or 6. Here this is 1, 4, or 6. No, sorry. What did I do? So 1, 2, or 6. And here 1, 4, or 6. That's correct. And this is 3, 4, or 5. And actually this one there makes this a 5, this a 3. That's not 5. So that's not 5. And we are almost there. Oh, see that? A 3 here would work as Parity Party. I'm tempted to put the clue even though I don't use it. And here 2 works. Even if the clue is not useful, this is so nice. And it's so nice and so disappointing. Wait, what did I do? Oh, sorry. I pencil marked 3s instead of 1s here. This is so frustrating. In some cases, you would add something to just disambiguate the lot. But let's try to see. Does it work with the 6? If I put a 6, then this is 3, 1, and 2. That's 6, 4, 5, 3, 1, 6, 2 here, 5, 4, and 1. That works. And obviously, if I put 6 here, it's the same with the switched rows. The issue here is that I've got nothing to disambiguate those rows. Those 5s and 2s don't do anything to disambiguate this. So this 3 clue was very powerful, but too strong, I'd say. So I could use something more on the lazy side of things, but I won't do that. I don't want to add another rule to those I've been using at this point. What if I put a second 2 here? Well, if this is a parity party clue, then this has to be a 2. Let's see what happens. Oops. So there's no 1 here, so there has to be a 1 here. Oh yes, there's a 4 somewhere there, so that's a 5, that's a 4. That's 5, that's 3. And there again, those two rows can't be disambiguated. I must find something. Oh no. I was thinking of putting a 3 here. But that would work as Parity Party. So it would add nothing. 3 here would add nothing. It would work as a Skyscrapers clue. So this is 3 here would work as a skyscraper clue. It would give nothing else. So I don't think this 2 clue is well, let's just see what it does if we use it as a skyscrapers clue. And let's not forget that this can't be a 4. So as a skyscrapers clue, this would be a 5, hiding all those digits, all those buildings. That's 4, that's 1. That's 5, that's 3. 5 here. And the same issues. So 2 here is not a bad clue, 2 here would not be a bad clue either. Actually, it would work with both 2 and 4. But I must find something to disambiguate. What about the 3 here? I've probably already tried something along those lines. Actually, 3 here would have a lot of options. Could be 1 and 2. So what does it do? Well, basically nothing. Especially knowing that it could be 2 and 5. So 1 and 2 would have worked as a Parity Party clue, 2 and 5 work as a skyscraper clue. And we're left with basically the same as what happened before. So I must work on this. Or maybe find something here. What about the 2 here? Well, 2 here would have a number of options. Could be digit 2, and then we would be faced with, well, the same issues as before. I really need to focus on how to disambiguate those 2 rows. Of course, I could put a 3 somewhere. Maybe I'll do that in the end. Or a 2 somewhere. What if I put a 2 here. Symmetry is completely broken, but we still have kind of pairs. So what can happen? It has to be a skyscraper's clue, and well, 5 would work. 5 always works with a clue of 2. Or does it? Yes, it works. Always does. Would it work with 3? If I'm doing this, then this has to be a 2, so we have a 1-3 pair here. So this is 6. Oh no, it doesn't work with a 3. Because 5 will be somewhere, 5 will be here, actually. Also, this 2 needs this to be a 5. So knowing that this is 2, we have a 1-3 pair here. That's a 4, that's a 6. Here we have a 1-2 pair, and here we have a 4-6 pair. And this is still not resolved, but that's definitely some progress. I'm tempted to put a 3 here, just because it works both as Parity Party clue and Skyscrapers clue. And actually seeing 1, 2, 3, 4 here looks quite nice. Now the question is, would a clue of 3 here work? It would still retain some measure of symmetry, and actually it seems to work. It wouldn't be a Parity Party clue, so it would have to be Skyscrapers, but 4 wouldn't work as a skyscraper. Because we would see 4, 6, we would only see 2 buildings. So that's a 2. That's a 2. So 1, 6, 4, 2. I'm afraid it won't resolve to the end. 1, 5. And there are still quite a number of solutions. We're almost there. So we could see another clue somewhere. A 3 here would be nice. But I'm tempted to try something else first. I'd like to put a last 3 and have the puzzle unique. So how do I do that? At this point, this is 1, 2, or 5. Why does it do that? So at this point, we don't have that many solutions. So I've tried 3 here, didn't work. What about 3 here? Or 3 there. That's interesting. What about the 3 there. Of course, we will lose the symmetry then. We're bound to lose it anyway. It's tempted to use the Parity Party version of it. 5, 2, 5, 4, and all of this resolves. If we use Parity Party, then this has only one option. Can it be a skyscraper? If this is skyscrapers, then I must remove this 5, which means that in both cases I must remove the 5. Does one work for skyscrapers? Yes, if I put a 5 here. And this doesn't even have a unique solution. So 3 here is no good. So 3 here has too many options. That's not a proper way to do that. I think I have tried to put a 3 here. I may have tried that multiple times. So what did it do? Well, of course 5 will never be here. Oh yes, I remember that 2, 5 here would work, but so would 1 and 2. And this would not be unique anyway. So 3 here is not good. The final touch can be very frustrating. Did I try 3 here? So 5 is removed. So that this must be a 5. Right? So that's a skyscraper's clue. And I'm afraid that everything works. 1, 4, 6, 4, 5, 6, everything works. Bobbins. Is there anything I haven't tried? 3 here? 3 here works, I think. Yes, that's 4. It needs to be a 5. Yes, that works. Well, that's probably an option I had left out earlier. I think I had removed this option earlier because it was too brutal and because there was no disambiguation that we'll add later here. So that seems to work. But something you need to understand is that it's not finished. The process of creating the puzzle is not finished because now I've done a lot of back and forth stuff, and I can very well have made mistakes. Mistakes like taking things for granted where I shouldn't have. Like what we call logical leaps. And this is the right moment for testing. So let's create the testing puzzle. So do you see? Yes, you see the puzzle. So I've created the puzzle, and now I'm trying to test solve myself, and if it works, then I will submit this to testers, and I'm certain that Glam Hippo will like the idea. Alright, so of course the bias is that we know what has to be done. We know that this has to be a 1/6 pair, but let's do the logic again. We must conduct a thorough test. So if this is a parity party clue, then this has to be a 1. If this is a skyscraper clue, then this has to be a 6. Alright, no worries, this works, this absolutely works. If this is a skyscraper clue, then it puts a 6 here, that breaks. So those are both parity party clues. If we stop at the first even digit, then this has to be a 6, plain 6. This is left as an exercise. Oh, sorry, that's not the right, no. Sorry, let's do it again. If we start with an even digit, then this has to be a 6. And this is really a good exercise, so I leave it to you. But if we start with an odd digit, then we must have 2 of them, because we end on an even digit, so the sum of odd digits must be even, so there must be an even number of odd digits, in which case they are a 1/3 pair. So this is either starting with the 1 or 3, with 1 and 3 somewhere, or with 6, and 2 is in this position, on whichever line works, and 4, and there must be 4 and 5 here or there. We'll talk about this when we understand what happens with 5. So we know now that this 2 has to be a skyscraper's clue, and we can deduce that this 5 can't be a skyscraper's clue, because in this case we would have to put 6 here, and all digits here would be seen, but we know that 2 here will be hidden. So this is a parity party clue, so it has to be either a 1/4 pair or a single 5. This is not a skyscraper clue either, because then 6 would have to be here, so this is also a parity party clue, but we don't know much about it. We know that those clues can't both be parity. They can't both be skyscraper clues, because they would both put a 6 in this region. So one of them at least has to be a parity party clue, but parity party clue would be a 4 anyway. So one of them is really a skyscraper's clue. And how do we decide? Let's pencil mark, well, that's some silly pencil marking. Well, that's really silly. I agree with myself. So how do we decide on which one to overrule? No, to rule out, sorry. And actually this one is more constrained, because if we try the skyscraper clue here, then 6 has to be here or there. But if we try the skyscraper clue here, 6 has to be here. So that's the one that looks the more promising in terms of implications. So let's try to put a skyscraper clue here. So 4 is here, 6 is there, and this starts with 2 or 3, in which case this can now only be a parity party starting with 5. We know that this digit and this digit are hidden, so those are in ascending order. This can't be 1, and this can't be 4, so it's at most 3, and this is at least 2. And we see then that this 5 can't be fulfilled, because it would have to be 1 and 4, and that we have 1 and 4 here. Of course, that's the logic we already encountered. We have to do that again. So 4 is not here. That's still not easy logic. Oh, sorry, 4 has to be here. On the contrary. And now this is a skyscraper clue. So it must start with 2 or 3. There must be a 6 somewhere here. And we now know that because of this 5, because of this, the only option is 5. We can't have 2 and 3, we can't have 1 and 4. So this is a 1, and because of this 5, this is a 4, which places 6 here. And 5 by Sudoku goes here. That's a 2-3 pair. That's a 6. And because 5 is hidden and 1 is hidden, 2 and 3 must be seen, so 2 is here. That's a 1-3 pair. That's a 3-5 pair. But now this 5 here wouldn't work with the 3 clue. So that's a 3, that's a 5, which is much easier than the way I ruled this 3 out, but that's good. And because this is 3, this 6 now has to be a single 6. It won't be 1-3-2. So that's the 2. And that's the 1-3 pair. By Sudoku we get 5 and 4. That's a 3 and a 6. And because this is now a skyscraper's clue, that's a 3, that's a 6. That's a 1, that's a 6. Here we have 1 and 2. Here we have 4 and 6. Let's do some classic eliminations. Here, this is 2 or 5. Here, this is 2 or 4. Here we have 3 candidates. Well, I like to pencil mark a lot, as you may have noticed. I know some people, some very good competitors do that much, well, they are, how would you say, they have an economy. They use very little pencil marking. So is this correct? 2 or 5, yes, that's true. 2 or 4, that's correct. So now this 3 obviously won't be a parity party clue, so it must be skyscrapers. So whatever the digit here, that has to be a 5. And this is where I'm starting to fear something has been lost in the earlier logic. So that's a 5, and this is not unique. And that's a massive bobbins, except, no, not except, this really is not unique. That's really, really annoying. So back to this. Well, let's just rewind to the point, to this point. How did I decide that there had to be a 2 somewhere here? Oh, digits are not the same. Oh, this was completely wrong. That didn't work at all. Oh. Well, that's some major... that's some major blunder. Because this works. This did not work. Something was misplaced between 3s and 6s. But that's actually very interesting because now I can't delete this 3. Because now let's just disregard this 3. All my stuff was completely wrong. But now, would a 3 here work? What happens with a 3 here? And let's disregard this 3. 4 wouldn't work, so it has to be a 2. And actually this 3 works as well, but I think this is working. This is wonderful. Now I have symmetry. Let's do it again. So I remove this. I put a 3 here. And I do the snapshot again because now that I have something that seems to work, well, I shouldn't have snapshot with the wrong digits, I know, but I'm about to delete the digits in solution mode. And let's just imagine I had deleted the digits in problem mode, then this would have been lost. And that would have been a big moment of dismay. So now, it looks like this should work, in which case just look at the layout of digits. Let's do it again. So I'm selecting generate URL with answer check, open. Congratulations. Well, I guess congratulations, yes. So, oh no, this is badly framed, so the frame is correct here. So let's do that again. So this is 1 and 6. This is 1, 3, 6 with a 6 somewhere here. 2 has to be here. This is 1, 4, 6. It can't be 2 and 3. just know that this is a skyscraper's clue, doesn't say much. So here, we saw that a skyscraper here wouldn't work because we put a 6 here. This digit would be hidden. So what was the logic again? Oh, this would have to be a 4, the Parity Party clue. So this would have to be 2 or 3. But then 3 here would need to put 4 and 5 somewhere here, so 4 would have to be here. That wouldn't work. 2, I would need a 3 somewhere, then a 5. So 4 and 1 would be hidden. Because of this, we know that this is 5, so 3 is here. We get a 1-4 pair here and a 1-4 pair here, so it doesn't work. Yes, I'm doing the logic all over again, and I think that's important. This is 2 or 3, so this is 5, this is 1, this is 4. And oh, sorry, this 6 has to be removed. It has to be here for the skyscrapers. So that's a 6. Now we see 2 has to be seen. This is 1-3 pair, so that's a 5. That's a 2-3 pair. That's a 3-5 pair, but 5 wouldn't work with the 3. And 3 works with the 3 as a Parity Party clue, and in the end, I think it should work as well as a skyscraper's clue, which is nice. And I have to be careful in the wording of the rule to say that they are not mutually exclusive. It can be, it has to be a clue for at least one of the set of rules. So this is so the 2 and 1 and 3 is here. That's a 6. That's 5. That's 4. 3 and 6. Because of the skyscrapers, that's 3 and 6 in this order. Here I have a 6 and a 4. Here a 1-2 pair. And now, because of this 3, we know that it won't be Parity Party because it would have to be 1 and 2 or a 3. So it's a skyscrapers. So 4 can't be in first position. So that's a 4. And that's a 2. And now it shows, I think. That's a 3, that's a 5. That's a 1, that's a 4. 3 and 1, 2 and 3. 5 and 2. Seems to work. So now I just have to proudly put it to the test and proudly publish this video on my channel as a setters video. If you made it this far, then I'm glad. I hope you learned something. I hope you learned something about how to construct a puzzle. There's still one thing. How did I come up with this rule? Well, I didn't invent any of the rules, actually. I didn't invent Sudoku rules. I didn't invent the rules of skyscrapers. I didn't even invent the rules of Parity Party. But I've noticed that the values of the clues of those two may be in the same range. Actually, there are much higher Parity Party clues, but numbers from 1 to 6 are valid values for this. And so it just occurred to me. To be honest, initially I considered doing just a hybrid of skyscrapers and Parity Party. It's really in the few minutes before starting to do this video that I thought it would be really nice to have this ambiguity stuff. I had no idea it would work so well and with such a stunning visual result. Well, anyway, I hope you learned something. I hope you enjoyed all this process, seeing my blunders and everything. And see you soon on SudoKanard. Thanks for everything. Hey, hey, hey. Say hello, bonjour, et au revoir.